Hi everyone, welcome to Python Osmosis episode 31, the screencast that dresses up your Python formatting but doesn't take it out. I'm Ryan Shea, and in this episode we'll be talking about fancier output formatting. So we've talked about a few different ways of getting output to the screen. Print, hello world, obviously print is there. We can say, just use an expression, hello world, and there's hello world. And another way is to create a file equals open, just create a file for writing, and we'll write to this file foo file, and we can use the write method of that, and we'll put out bar, just a string bar, write that out to the file. So those are three different ways we can get output. Another way is the standard module string contains a method called format, and format is a way that you can put fancier outputting out to the screen. But of course we have to turn things into a string first in order to use that string standard module. So how do we do that? Well, we've seen with print that we can print out any object and something will happen. So print, let's say 1, 2, 3, and actually make that 3 an integer, and you see that it does actually print out to the screen something that looks to us pretty friendly. And what that's using is the str function. So str is designed to turn something that is an object into sort of a human readable format. Often the same as what we see with str. The str function is something called repr. And repr is designed a little bit more to be for the interpreter rather than for a person. A lot of times it ends up being the same, but let me highlight some examples where it's actually different. So the first and most notable is in fact a string. So s equals hello world. Okay, so now we have a string hello world, and let's do the str function on that and see what it looks like. Okay, no big surprises there. We have the single quotes in the string representation, and everything looks fine. Now if we do repr on s, it now sort of contained that entire single quoted version inside a set of double quotes. So it sort of further encapsulated it. And that's one difference, the str versus repr for string types. Also for integers and for floats, let's do a float. Str 0.1. Again, no surprises here, single quotes, 0.1. But repr, more interpreter friendly, 0.1. We see this quoted string with all the zeros and that kind of final 1 there. Let's do a little bit more with repr of some numbers. These are integers in this case. Actually, we'll do a float and then an integer. X equals 10 times 3.25, and y equals 200 times 200. All right, and then we'll do a formatted string output. S equals the value of x is, and we'll concatenate that with repr of x, concatenate that with comma, and y is, concatenate that with, repr y, and then just for good luck we'll add on a dot dot dot. Okay, and then if we print on this, we see the value of x is 32.5 and y is 40,000, dot dot dot. So yeah, no problem. Repr works out just fine for us in that situation. Now, let's say we had a string hello, and that was equal to hello world \n. Now if we print hello, we see hello world, and we see that extra carriage return that's in there. We didn't see a \n, we just it did the carriage return for us and made it more human readable. Now if I said hellos equals repr on hello, and then I printed hellos, you see hello, comma, world, \n. So again, more interpreter-friendly version of the string. It knows what \n is, but when I see that as a human, I want to see that carriage return put in there. And you can actually use repr on just about any Python object. Let's take a look. Repr, and we'll do something a little bit more complex. X, comma, Y will make sort of a tuple of there's a tuple with a tuple contained within it. Okay, and then you see, yeah, it stringifies this whole thing in single quotes, and the strings within that or I'm sorry, double quotes, and the strings within that are in single quotes. So that gives you sort of an overview of repr versus stir. That'll actually come in more handy later on when we're creating classes as well, because then you can define how you want your repr and stir to represent your object type. Let's go through a couple of different ways of creating a table of squares and cubes. So let's do a loop here for x in range 1, 11. Print repr x dot rjust. This we haven't talked about too much yet. Rjust is a string method, and we can pass it a number, sort of a number to buffer out that string to. So we're going to write justify, and we're going to leave this column with 2 characters as its sort of its width, and then we're going to have repr x times x, the square, whoops, dot rjust 3. A couple of things to note here. I just have a comma between the things that I'm passing to print. So this is automatically going to put a space between my columns. Just because this line is getting a little bit long, I'm just going to leave a comma here, and that will make sure that the print doesn't put a carriage return at the end. And then I'll just do another line here, print repr, and no shocker, x times x for the cube dot rjust. Gotta make room for those big numbers. 4. So now we're going to go through basically 1 to 10 here and print out the numbers and squares and cubes. So let's take a look, and yep, this makes a lot of sense. You see that it's right justified. The 10, it matches up with the 9. This whole column is right justified. There's that space that comes for free just by having commas between our print, the things that we pass to print. And this is buffered to 3 characters, and this one is buffered out to 4 characters, as we see in the rjust there. Another way of accomplishing the same goal is with the format method that I mentioned a little bit earlier of the string module. So for x in range 1, 11 again, up to but not include, from 1 up to but not including 11, print, and we're going to put a print string in here. This will look a little bit strange at first, but 0, this is going to represent what the 0th element, if you will, of what we're passing into this. And then I'm going to say 2D. So a width of 2, and this is a decimal that I'm sending, space, and I'm manually putting in the space here, unlike the separated out, comma separated print list. And then I'm going to have 1, the first element, and then 3D. So same sort of thing. That's buffered out 3, and this is getting a digit, and 2, and 4D. So a column that is 4 wide and expecting a digit, dot. Now, again, this is a string method, so this whole thing is a format string. All I've done is specified a string here. But when I use the format method dot format, and I'm going to put in x comma x times x comma x times x times x. Okay, so to go a little bit more slowly through this, looping through the range from 1 to 10, taking out x, and then just sort of defining how our formatting is going to be with this format string. 0 goes along with the 0th thing we sent in this tuple, which in this case is x. 1 goes along with x times x. 2 goes along with x times x times x. Those are the three things that we're passing in, and these define the formatting after this full colon here. A digit column that's 2 wide, okay, and digit column that's 3 wide, 4 wide. And these spaces in here are significant. That's what's actually going to give us the spacing between. This is going to look exactly like our last table. Same goal, different approach. So just once again, doing repr and rjust, the rjust method of a string, or using a formatted print string that's built into the string format method. So that's pretty useful. Another thing that can be useful is for buffering out, let's say a number or a float. So let's do, and again, these are string formatting methods. There's a method called zfill. And what this is going to do is just that. Zfill will take and fill up to 5 digits here. So we could put, obviously any number in there, and it will just, zfill stands for zero fill, so it's formatting, filling out with zeros. And in this case, this is the same number. 12 is the same as 0000012, and that is zfill for you. You can do the same thing with negative numbers, which is actually negative numbers, and with floats. So let's do 3.14, sort of a pi here. And this is, notice we put 8. It was smart. It knew that this number was negative 1, 2, 3, 4, 5, 6, 7, 8 characters that Z filled out to, and that did count that negative there. So let's do a little bit more with the format method. Print, these are curly braces, 0, whoops, and 1 dot format spam eggs. So this is just showing an example of strings rather than the x squared, x cubed type thing, and you see spam and eggs. You can actually swap these around, so it doesn't have to be in order. So I said 0, I said 1, and those just call over to the 0th item of this tuple, or the first item of the tuple. Let's swap those around. 0, go back over here, put 1. We want to print eggs before we print spam, and sure enough, eggs and spam. So you can do that. Another way that you can do this is you could have a keyword argument list. So print this. So rather than using 0, I'm going to use a keyword here. Is, this food is adjective. Period. Dot format. So that was our format string. And then in here, no surprises, we're going to put in a set of keyword arguments just like we'd send to a definition. Food equals spam. Adjective equals absolutely horrible. Okay, and we see this spam is absolutely horrible. with the period at the end, and that worked just fine. So keyword arguments, same as a definition. Let's do another example. Print the story of 0, 1, and other. This is going to show you that you can use both numerical representations or keyword representations in this formatting string format, and then we'll show the positionals first. Bill, Manfred, and then we'll do other equals Georg. Whoops, let's make that a string. Okay, and yeah, that worked. So positional first, and then we had the keyword, and it worked just fine. 0, 1, other. Let's import math here. We're going to use pi. So the value of pi is approximately, and this we looked at a little bit before, 0. So the we can have more like printf type functionality in here. So I'm going to take the 0th thing that I send, and I'm going to make that a float that has 3 floating points of precision. Period. Dot would help. Otherwise, Python won't know it's a method. Okay. We're going to call math.py in there, or put in that value, and you see the value of math.py is approximately 3.142, so it rounded off to those 0.3 f. That's just standard formatting string way of putting, sprintf style. .3 f was the float that it was getting. So that gave us a way to round. Take a look at another one. Let's make a table. If we had a dictionary, I'm going to copy and paste this. Alright, so we've got a dictionary. Oh. Copy and paste again. Okay. So for name, phone, in table.items, items, if you remember, is going to give us back the kind of key and value. Print 0, 10. Okay, that's going to give us a column of 10 characters. And this is sort of an easier way, rather than specifying what that is, whether it's a S or D. Or we can do 10D over here. So now we are actually specifying. And then we're going to pass into this the name and the phone that we got from the items method. We'll take a look. So yeah, that automatically buffered it out to 10. In this case, it was left justified out to 10. And even though these names were different lengths, it's fine. The next thing that was printed out within that formatting string, that space followed by the 2 equals, the greater than sign, and then a space, and then continue on with our next column, which was 10 decimal places. And yep, that worked just fine. Printed out the name and phone. Okay, so another thing that you might want to do is specify a name. A lot of times this can be kind of confusing, seeing the 0 or the 1. You might want to specify a name in there, and you may be looping through a let's say a list of tables, and you want to just be able to call by the key within that table. So let's take a look. Actually, it's going to be the same table as before, and let's print out Jack, and then I want to call it by name here. So Jack, which is a digit. I'm not even going to attempt to pronounce that name. And then and decab, which is again a digit, dot format, and check this out. Unpack the table into there. Okay, so now I'm just calling directly by name rather than using this 0. I can just call, this is sort of the same thing that we did with unpacking a dictionary into a definition and sending it through as keyword arguments. This is sort of doing the same thing. We're just doing keyword arguments again, and we can just loop through and send in unpacking that table. And yep, worked just fine. So that's str.format for you. It changes up a little bit with Python 3, but that's all for now. This screencast is directly inspired by the official Python tutorial by Guido van Rossum at python.org.